Our case study for General Biology 112 called Into Thin Air. The story begins with a six-person expedition team climbing Mount Denali in Alaska, which is 17,660 feet. The lead climber is Tom Benman, an expedition frontman, so he was in the front of the line. Emily Norman was a registered nurse. John was the assistant expedition leader and seasoned alpinist. Mark McKinley was the least experienced climber and what this case study is about. And then the last one was Pete, the expedition's final climber. They were going up the mountain, and Emily Norman, the registered nurse, was following behind Mark, the inexperienced climber, and she noticed that he started having labored breathing, so she asked if he wanted to stop because her head was also hurting. Once they stopped, Emily noticed that Mark's breathing was still labored and not getting better, so she called to Tom and told him to stop so they could return back to a lower altitude. The physiological problems that humans encounter at high altitudes are the lack of oxygen and extreme cold temperatures. When climbing in high altitudes, the climbers experienced headaches and dizziness due to the lack of oxygen. They experienced shortness of breath because of the low pressure in the atmosphere. The headache was also caused by the lack of oxygen to the lungs and into the body tissues. Hypoxia is the deficient amount of oxygen reaching the tissues. The air at 18,000 feet is significantly less dense than the air at sea level. There are little changes in the composition of the air, which means that there's still oxygen and nitrogen in the air, but it's less dense, so one breath you get less oxygen in. The pulmonary response was to breathe faster to provide the body with more oxygen. The blood gases were affected since there was less oxygen available, and so there was less oxygen binding to the hemoglobin. And there were also deprived cells because of the hemoglobin was not getting the proper oxygen it needed. The 2,3-DPG is diphosphoglycerate, which controls the movement of oxygen from erythrocytes or red blood cells to body tissues. This increases with time at high altitudes to make oxygen transfer easier, so the rapid breathing will slowly go away when that increases.
So John, who's the expedition leader and experienced mountain climber, helped guide Mark down the steep trail. Emily and Pete asked if Mark was okay, where Emily responded with how she explained why they spent a prep month training at 15,000 feet. The psychological changes, which were increased to 2,3-DPG in hemoglobin levels, which allows blood in the tissues to adjust to the high altitudes. These changes help the body adjust and perform the necessary functions at a higher altitude where oxygen isn't as available. The physiological pathway throughout the body would be stimulus to production cell to target cell to response, which is production cell of kidney and EPO hormone, which is erythropoietin, which is EPO, is a hormone produced by the kidneys which promotes formation of erythrocytes or RBC by the bone marrow. Kidney cells that make EPO are sensitive to low oxygen levels. Production of red blood cells equals more hemoglobin and blood to help with efficient O2 levels in body tissues. So Mark started deteriorating rapidly and had lost consciousness by the time they reached the lower altitude. They worked quickly because of Mark's condition, so Emily called for help while Pete, Tom, and John carried Mark the rest of the way. Airlift was on the way and will be there in an hour. They started stabilizing Mark with oxygen and a pressurization bag. 90 minutes later, Mark is unresponsive at the hospital where Emily tried to phone Mark's family. The oxygen and gamma bag would help Mark return to a normal environment with efficient oxygen and pressure. I would make sure to run tests for the oxygen concentration levels, edema, HR tests, RBC count, chest x-ray, and brain responses. Taking the test would make sure levels were healthy and no damage to organs or body tissues. I would expect to find low oxygen levels, edema in lungs and brain, high RBC, and hazy consciousness. This would be because of the high altitude and circumstances.
After they get to the hospital, they run a blood test, and the results are from the arterial oxygen. We saw low oxygen levels in the blood, and then the carbon dioxide was in low levels. The blood was on the acidic side. There was a high level of red blood cells, which could be due to the body's response in trying to get more oxygen to the body tissues. The arterial glucose, urea, nitrogen, creatine, potassium, and sodium were all in normal levels. The bicarbonate was in low levels, which can mean acidosis, which is too much acid in the blood, which can lead to diarrhea, kidney disease, and liver failure. And the chloride was also in normal levels, and no prescription medicines were found for him. There was also tests run for pulmonary functions. The inspired oxygen tension showed that there was low oxygen. The vapor pressure was low. The alveolar oxygen was high, and the respirator quotient estimates that the basic metabolic rate was low, which means the cells weren't able to do the normal functions that they needed to do to survive. The tidal volume was also low, which means that the air in the lungs was low. The heart rate was normal, and the blood pressure was also normal. The results correspond to our predictions, and the values agree with the predictions of a high red blood cell count, low oxygen levels in the blood, and other values agree with the diagnosis of edema in the lungs. The most serious values were the low levels of oxygen in the body, because the tissues may have long-term effects or fatal effects due to the lack of oxygen. The alveolar oxygen tension is high, while the arterial oxygen levels are extremely low. This may be a result of edema in the lungs that prevent the gas exchange into the bloodstream. The lungs have the oxygen while there is little oxygen in the blood. With all the tests and results, we can conclude that Mark may have altitude sickness, and his lack of oxygen and exertion may have led to this.
At Denali Valley Hospital at 8 p.m., Emily tells Mark that he has pulmonary edema. High altitude pulmonary edema is rare but very serious. Mark is susceptible to recurrences, which means he has to be careful climbing from now on.